In this lecture, we will learn how to use truth tables as a means of testing arguments for validity. So let's go ahead and begin by looking at an example. Consider the following argument sequence. You should recognize this. This is half of one of De Morgan's laws. It's also the RAA bonus problem, which we have already seen is somewhat difficult to prove using only our primitive rules. But it turns out that there's another way to demonstrate that this sequence is valid. We can do it by using a truth table. So remember our definition of validity. Our definition of validity tells us that an argument is valid just in case it is not possible for all of its premises to be true, but for its conclusion to be false. So one way to show that an argument is valid is to use a truth table to show that there are no possible cases in which all of its premises are true, but its conclusion is false. So let's look at how to do that for the sequence we are now considering. So I'm going to set up a truth table here. Note that I have the premises, in this case there's only one premise. I have the premises of my sequence on the left here, and I have the conclusion on the right. Now I'm going to go ahead and just set up my truth table here. So here's all my possible combinations of truth values for P and Q. I'm going to begin by evaluating the premise of my sequence. So in order to do that, my premise is the negation of this conjunction here. I'm going to begin by writing down the truth values for the parts of the conjuncts of the conjunction. So I'll begin by writing down the truth values for P. Of course, all I need to do is copy the column for P over on the left over here. Likewise for Q. Now I'll focus on evaluating this conjunction. Well, a conjunction is true under only one condition, that is, when both of the conjuncts are true. We see that condition occurs only on the top row here. So this row that I have marked, the top row, is the one and only case where this conjunction is true. So in every other case, it is false. Okay, now I'll go ahead and evaluate the negation of this conjunction. Of course, negation signs simply flip truth values. So all I've done here is taken the conditions under which the conjunction is either true or false and flip the truth values here over on the left under the negation sign. And that gives me the conditions under which the premise of my sequence is either true or false. Okay, now I'm going to go ahead and focus on the conclusion. The conclusion here is a disjunction. Note that the disjuncts of this disjunction are just the negations of P and Q. So what I've done is I've just taken the column for P over on the far left there and copied it over here, except flipped the truth values because I've got the negation of P, and I've done the same for the negation of Q. Okay, this is a disjunction. A disjunction is false in only one kind of case, namely the case in which both the disjuncts are false. The only place that occurs here is on the very top row, so everywhere else this disjunction is true. Okay, so now that I have this truth table laid out, I want to examine it to see whether there are any cases in which all the premises of the argument are true, but the conclusion is false. So in order to do that, I'm going to look over at the conclusion and I'm going to look at the cases where it is false. Well, there's only one case where it's false. So this is the one case where I may see that my argument is invalid. If it's invalid, then I'll have at least some cases in which the premises are true, but the conclusion is false. So here's a case where the conclusion is false. Now I'll go and I'll check the premise, and I'll see if the premise is true. If it is, then I'll have a counterexample to the validity of this argument. I'll have a case in which the premises are true, but the conclusion is false. But when I look at the premise, I see that it is also false. So, in the one and only case where this argument has a false conclusion, it also has a false premise. And that's fine. That doesn't count against its validity. What matters is whether there are any cases in which the premise is true but the conclusion is false. But now I see that there are no such cases. In every case in which the premise is true, the conclusion is true. So that tells me that there are no possible conditions under which the premise is true but the conclusion is false. So that tells me that this argument is valid. So I have a valid argument here. Okay, let's look at another example. Consider this sequent. If P then Q, Q, therefore P. Okay, we have already seen that this argument pattern is not valid. Here is a counterexample to it. If it's raining, the streets are getting wet. If P then Q. If it's raining, then the streets are getting wet. The streets are getting wet, that is Q. Therefore, it is raining. We have seen that this is not a valid argument. It is possible for the premises of this argument to be true, but for its conclusion to be false. It is possible that it's true that if it's raining, the streets are getting wet, and the streets are getting wet, but false that it is raining. Perhaps the reason the streets are getting wet is the sprinklers are on, and it's not raining. Okay, so before though, when we looked at examples like this, we were reliant on our ability to think of counterexamples like the one I just provided. We had not yet introduced any systematic way of testing arguments like this to see whether they're valid. But now we have such a systematic way. We can show that this argument is not valid using a truth table test for validity. So here's how it goes. I've set up this truth table here. I have the premises of my argument on the left and the conclusion on the right. So I put in all my possible combinations of truth values for P and Q. Okay, so now I want to start filling in this truth table. So I'll start with this premise here, the conditional if P then Q. I'm going to take a little shortcut here. I note that this is a conditional. A conditional is false in only one kind of case, namely when its antecedent is true and its consequent is false. So this conditional will turn out to be false only in the case when P is true and Q is false. And that occurs in only one place here, namely on the second row of the truth table. So in every other case, this conditional is true. Okay, now I'm going to evaluate Q, the other premise of this argument. Of course, that's pretty easy. All I need to do is copy down the column for Q over there from the left. Now I'm going to look at the conclusion. The conclusion is P. Of course, it's easy to find the truth values for it too. All I do is copy down the column for P that I have over there on the far left. Okay, so now I've got my truth table. I am going to look at it and see. First, I'm going to examine it, and I'm going to find the cases where the conclusion is false. So here's one such case. Down here on the third row of the truth table, the conclusion is false. Now I'm going to look over at the premises and see whether all the premises are true. Well, it turns out they all are true. So here's a case in which all the premises are true, but the conclusion is false. That is a red flag. This row of the truth table is a counterexample to the validity of this argument. It shows me a kind of condition in which the premises of this argument are true, but its conclusion is false. So it's possible for all the premises of this argument to be true, but for its conclusion to be false. So I may conclude that this sequent is not valid. Now, I have another case in which this argument has a false conclusion, namely the bottom row. The bottom row, though, doesn't furnish me with a counterexample to the validity of this argument. The reason is that even though the conclusion is false on the bottom row, one of the premises, namely Q, is also false on the bottom row. So this is just a case where you have a false conclusion but also a false premise, so that doesn't count against the validity of the argument. But it only takes one kind of case in which all the premises are true and the conclusion is false for the argument to be not valid, and we have that case on the third row. So we're entitled to conclude from our truth table test that this argument is not valid. Okay, so now you can use truth tables to test the validity of an argument. What you do is you put the premises of the argument to the left, the conclusion to the right, you write out the truth table, and then you examine the conclusion for the conditions in which it is false. And then you look and see if on those rows the premises are true. If you have rows where all the premises are true but the conclusion is false, then your argument is not valid. If you have no such rows, if it is the case that on every row in which all the premises are true, the conclusion is also true, then your argument is valid. Okay, so now that I've shown you how to use truth tables to test arguments for validity, I'll go ahead and allow you to practice that through your homework assignment.